So we've been looking at some conversions between moles and grams and moles. Now we're going to actually discuss why this is so useful and effective for chemists. And the reason why is because chemists, while they can't convert between grams of one substance into grams of another substance using a balanced chemical equation, they can convert between moles of one substance and moles of another substance. So if you think about this equation right here, 2H plus O2 goes to 2H2O. Well, we know that if we have two molecules of hydrogen and one molecule of oxygen, we'll be able to get two molecules of H2O. But now consider what happens if we increase these or multiply each of these coefficients by mole. Okay, so 2 moles of hydrogen molecules, 2 moles of oxygen molecules, and 2 moles of water molecules. So now we got 2 and 1 and 2. All of a sudden, we actually have a ratio of hydrogen and oxygen and water that is valid on from what's called a stoichiometric aspect, but we can actually measure out that amount of hydrogen and oxygen and water because we have the molar masses for each of those individual things. And so if we get 4.0 grams of hydrogen, 32.0 grams of oxygen, and 36.0 grams of water, we should be able to essentially react both the hydrogen and the oxygen completely together and get 36.0 grams of water out. All we did was multiply from an atomic scale where we're looking at molecules to a molar scale where we're looking at moles of molecules. And so that's why this number, the mole, is so powerful. So let's consider the types of conversions that we can do and the types of conversions we can't do. So if we have grams of A, in our example, it was this would be like grams of hydrogen, and grams of B. So grams of oxygen. We can convert between grams of A and moles of A, but we can't convert between grams of A and moles of B directly. We have to go from grams of A to moles of A and then to moles of B. And we see, again going back to the last slide, that if we have 2 moles of hydrogen molecules, we need 1 mole of oxygen molecules in order to completely react. And that's what we're saying. We can use the coefficients from the balanced reaction to convert between moles of one substance and moles of another substance. Now this could be the reactants, or a conversion between one reactant and another reactant, or conversion between one of the reactants and one of the products, or even a conversion between one of the products and one of the reactants. And so these moles to mole conversions can be done as long as you have a balanced chemical equation. So let's go ahead and see this in practice. Okay. Notice there are some other conversions you can do between moles of A to molecules of A, or moles of B to molecules of B. And these are the conversion factors that you need in order to do that particular conversion. So how many grams of water are produced in the combustion of 1.00 grams of glucose? So we're back to the C6H12O6. So this is the balanced chemical equation. We need 1 mole of C6H12O6 for every 6 moles of oxygen will produce 6 moles of carbon dioxide and 6 moles of water. And so now that we have that, if we convert this mass of glucose into moles of glucose, we can convert that directly from moles of glucose into moles of water. And the conversion will look something like this. But before we get to that conversion, there's one other thing we need. I almost forgot. We need to actually find the molar mass for C6H12O6. So, going back to my periodic table. Oh no. Alright, I got the periodic table ready. So going back to the periodic table, we're going to actually calculate the molar mass for both glucose and water. So looking at glucose here, a carbon has a molar mass of about 12.01 grams per mole. and there are 6 of them, so times 6. Hydrogen has a molar mass of 1.01 grams per mole, and there are 12 of these, and then oxygen has a molar mass of 16.00 grams per mole. And we'll multiply that by 6 also. So I'm going to go ahead and get the calculator. So here's our calculator, trusty dusty, and we go 12.01 times 6. So it's 72.06. Let me go ahead and put that, 72.06 grams per mole. This one I don't need a calculator. I believe it'll be 12.12 grams per mole. And then this one, I think I don't need a calculator. That one should be 96.00 grams per mole. Let me grab the calculator again for the addition. There it is. So 72.06 plus 12.12 plus 96.00 is 180.18. So going to this, 180.18 grams per mole is my molar mass for this particular for this compound. Now going to water, we have 2 hydrogens. So this is for glucose. So for water, we have 2 hydrogens. So 1.01 times 2, and 1 oxygen. So that's 16.00. Now that'll be 2, so that'll be 18.02 grams per mole. I did that one rather quick for H2O. So double check me on that one just in case I got it wrong, but I think it's correct. Okay, so moving over. So this is what the conversion will look like when we get this. We're starting with the 1.00 grams of C6H12O6, and I won't have room, so I might have to move down onto these new lines. Don't worry about it if I do. I'm just running out of room here. So here we go. Actually, let me pause the video and get rid of this and just have the numbers here. Alright, so we're back, and so now we're ready to go ahead and continue this, this calculation. So now that we have grams of C6H12O6 per 1 mole, we're going to go ahead and convert this into moles of C6H12O6. So we see from over here it's 180, well, we'll put grams on the bottom, mole on the top. Oh wait, we don't have a mole down here. So it's 1.00 grams of C6H12O6. Alright, so grams per mole, we see that we put 180.16 grams per 1 mole. And now we'll get grams to cancel here, and then we'll be in units of moles of C6H12O6. But we want to actually convert from moles of C6H12O6 to moles of water, and so we use the balanced chemical equation. From a balanced chemical equation, we'll get, let's see here, mole of C6H12O6, I've been saying H2, it's H12, per mole of H2O. Okay, so we have that. Now what coefficient, what do we put in here for the actual numbers? We put the coefficients from the balanced chemical equation. So we put a 1 here, because there's understood to be a 1 there, and a 6 here. So now that we have that, we want to go back to grams of water. So we need to have mole of H2O down here to cancel the moles there, and put grams of H2O up here. So we go back to the molar mass for water. So we put 18.02 on top and 1 mole on the bottom. And now look what happens to our units. Our grams cancel there, moles cancel with moles. The C6H12O6 here cancels with that there. Now we have moles and water canceling with moles and water here, and we'll get grams of H2O. So it goes equal sign, and I'm going to write that down here after we put it into our calculator. Oh wait, calculator, where are you? there you are. Okay. There we go. Oh, this is fun. Okay, so 100. Oh, excuse me. It's starting with 1 gram times 6. So we see 6 over here. Times 18.02 divided by everything on the bottom, 180.16. And that would give us our mass in grams. And so we say it's 6.001. If we look at our original mass that was given, it was 1.00, so we only need 3 sig figs. So we say that we end up with 0.600 grams of H2O.